radicals is what we're going to talk about today. And we're going to actually estimate and round the radicals to the nearest tenth. So write down the directions and write example 1. And for example 1, we are going to find the estimate rounded to the nearest tenth of the square root of 20. Just like yesterday, we're first going to break it down in between what two perfect squares the square root of 20 is in, and then go further to what two integers the square root of 20 is between. The two perfect squares that this number is between is the square root of 16 and the square root of 25. We have to determine what two integers this is between, which is 4 and 5. So the first thing we know about our answer is it's going to be 4 point something because it's between 4 and 5. And we're going to make a fraction first. So let's write our whole number as 4, and then we're going to do something to figure out what our fraction is going to be, and then change that fraction to a decimal. The first thing we're going to do is subtract these two numbers, just the radicands. 16 from 20 is 4. And then we're going to subtract these radicands. 16 minus 25 minus 16 is 9. That is actually going to be the numerator and the denominator for our fraction. Now we know our answer is going to be 4 point something, so we need to take this fraction and do a division problem to determine what our answer is going to be. So watch carefully so you know where to put the numbers. We have 4 divided by 9. So 4 divided by, when I say the words divided by, I make my division box. And then I know the 9 has to go on the outside. Because I'm rounding to the nearest tenth, I am going to put a decimal point and 2 zeros so I go far enough in the problem to round correctly. Go ahead and solve that division problem. I know that 9 goes into 4 0 times, so I'm going to put a 0 and bring up my decimal point. 9 goes into 40 4 times. 4 times 9 is 36. When I subtract, I get 4. Bring down the 0. And we know 9 goes into 44 times, and this is actually going to be repeating, but we're rounding to the nearest tenth, which is this number. We have to look to the number beside it to figure out whether to keep it as a 4 or move it up to a 5. And because 4 is less than 5, we're going to keep it as 0.4. So that means our answer, we're going to bring over this 4 and the decimal point, and so our answer would be 4.4, or 4 and 4/10. Here is example 2, the square root of 10. Go ahead and see if you can do this one by yourself. First thing we'll do is find the two perfect squares it is between, and that would be square root of 9 and square root of 16. Then those two integers would give you 3 and 4. So if this number is between 3 and 4, then you know it has to be 3 point something. So we know our answer will be 3 decimal point and then something after that. So we can go ahead and put a 3 down here. So you might draw an arrow that shows you we're going to put the 3 as our whole number. And then you always start on this side. You always start on the left side. You never do the difference between 10 and 16. You always do the difference between the ones on the left. So the difference between the radicands 9 and 10 would be 1. The difference between the radicands 9 and 16 would be 7. So our fraction is 1/7. And then we do our division problem. 1 divided by 7. So I have 0 and a decimal point. 7 goes into 10 one time. 1 times 7 is 7. When you subtract, you get 3. Bring down the 0. And 7 goes into 30 4 times. 4 times 7 is 28. I can stop there. So I know my decimal is the 10th place is right here. I'm going to look here to figure out how to round it. Because that 4 is there, I'm going to keep the 1. So my answer is 3.1. All right, here is example 3. The two perfect squares that this number is between is the square root of 81 and the square root of 100, which means the two integers would be 9 and 10. And so we know our answer is going to start with the whole number 9. So we would subtract these. And when you do that, you get 9. Subtract these, you get 19. So that's our fraction. Then we have to do the division problem. 9 divided by 19. 19 goes into 90 4 times, and you get 76. When you subtract that, you get 14. Bring down the 0. 19 goes into 140 7 times. So 7 times 19 is 133. And so we have the 4 to look at. Looking at the 7 means we're going to bump it up to a 5. So our answer would be 9.5. Now let's do example 4. It is negative square root of 5. You're going to do exactly the same way as we've been doing. You're just going to have a negative in your answer. The two perfect squares this number is between is negative square root of 4 and negative square root of 9. The two integers this would be between is negative 2 and negative 3, which means our answer is going to start with negative 2. Now I have to find my fraction. So I would find the difference between the radicands, which is 1. The difference between these radicands, which is 5. So I have negative 2 and 1/5. Now I have to turn that into a decimal. So I do 1 divided by 5. And it goes into it 2 times.
Teachers, please prepare for the afternoon announcement, stack chairs,
And so we know the answer.
And dispose them properly and place trash outside your door.
Negative 2.2. Here is the last example, example 5, the negative square root of 39. Go ahead and pause the video and see if you can work it by yourself. The two perfect squares it would be between is negative square root of 36 and negative square root of 49, which means it's going to be between negative 6 and negative 7. All the numbers on a number line between these two integers are going to begin with negative 6 and a decimal point. So I can go ahead and bring that down to start my answer. Then I have to do the math, finding the difference between those radicands, and that would be 3. Finding the difference between these radicands, and that would be 13. So then I get the fraction, 3/13. So now I come over here and do a math problem, a division problem. 3 divided by 13. 13 goes into 3 0 times. Bring up my decimal. 13 goes into 30 2 times. 2 times 13 is 28. You subtract that and get 2. I'm sorry. 2 times 13 is 26. And subtract that and you get 4. And bring down the 0. 13 goes into 40 3 times. 3 times 13 is 39. And you get 1. So we have our 0.2. We look at the 3. And we see that because it's 0.2, we don't change, because of the 3, we don't change the 2. So our final answer is negative, don't forget the negative, 6.2.